Science has always been an evolving story, a narrative stretching across centuries, built upon the discoveries of those who dared to challenge the status quo. Some theories are widely accepted, forming the backbone of modern science. Others, however, exist on the fringes, intriguing, unsettling, and controversial. They defy conventional wisdom, push the boundaries of understanding, and whisper possibilities that seem almost too strange to be true. But that's the beauty of scientific exploration. It's not just about what we know, it's about the questions that remain unanswered, the mysteries that linger at the edges of our comprehension. So tonight, as you close your eyes and drift into a restful state, let's embark on a journey through some of the most controversial scientific theories, ideas that may challenge your perception of reality, but will also guide you into the comforting embrace of sleep. The theory of evolution. Imagine standing on the edge of time itself, watching as the great river of life flows endlessly forward. It is a current that stretches back billions of years, weaving through the vast and intricate history of existence. Every creature that has ever walked the earth, swum in its oceans, or soared through its skies is part of this river, each one shaped by the gentle but unrelenting force of evolution. The process is slow, almost imperceptible, like the drifting of clouds across a twilight sky. But given enough time, small changes accumulate, and life in all its endless variety transforms into something new. The story of evolution begins not with the great beasts of the past, nor the towering forests or endless blue seas, but with something almost invisible, tiny, fragile, primitive life, forming in the warm, primordial waters of an ancient earth. It is a story older than memory, older than history, older even than the mountains and rivers that shape our world today. These first living beings, microscopic and simple, had no knowledge of what they would become. They merely existed, surviving in a world that had not yet known the touch of consciousness. But in their struggle to endure, something remarkable began to happen. Changes, so small and subtle that they could not be seen in a single lifetime, began to shape these tiny creatures. Some grew slightly better at gathering food. Others became just a little more efficient at surviving in harsh conditions. Over generations, these differences, though minor, determined who would thrive and who would fade into the shadows of time. This quiet, patient process, repeated over millions and billions of years, gave rise to every living thing that has ever existed, from the first single-celled organisms to the intricate, intelligent beings that now ponder the mystery of their own existence. There is something beautiful in the thought that every creature alive today, every bird, every tree, every insect, every person, carries within them the echoes of an unbroken chain of life, stretching back to the very dawn of time. No species simply appeared as it is now. Instead, each one has been shaped by a slow and unseen hand, sculpted by the quiet forces of nature into forms that could survive, adapt, and flourish. And yet, evolution is not a straight path. It is not a climb toward perfection, but a journey with countless twists and turns, a story with no final chapter. But like all great stories, evolution has its mysteries, its unanswered questions that linger like whispers in the dark. Fossils provide glimpses into the past, but they are scattered, incomplete, like pages torn from an ancient book. There are gaps in the record, transitions that are still uncertain, moments when change seems to happen too quickly, as though something unseen had nudged life forward in great leaps, rather than slow steps. Some wonder if natural selection alone is enough to explain the great complexity we see, or if there are forces we have yet to understand. Perhaps the greatest mystery is consciousness itself. Through the long journey of evolution, from the first single-celled organisms to the vast diversity of life on Earth today, something extraordinary emerged: the ability to think, to feel, to wonder. It is a gift we often take for granted, but one that remains among the most profound enigmas in science. Did consciousness arise simply as a survival mechanism, an accident of nature? Or is it something more, something fundamental to the very fabric of existence? Despite the controversies, evolution remains one of the most powerful explanations for the diversity of life on Earth. It tells us that change is inevitable, that nothing in nature is static, that life is a constant dance of adaptation and survival. Even now, evolution continues, shaping the future in ways we cannot yet see. The birds that sing outside your window, the trees that sway in the wind, even the smallest insect crawling upon the earth, all are still evolving, shifting, changing, carried forward by the same silent force that has shaped life for billions of years. Yet, despite its overwhelming evidence, the theory of evolution has faced resistance. For many, the idea that life is shaped by blind, indifferent forces rather than by a guiding hand is unsettling. It challenges long-held beliefs about purpose, about meaning, about humanity's place in the grand scheme of things. If we are not the center of creation, if we are merely one thread in the vast web of life, what does that mean for our existence? What does it mean to be human in a world where we are not the pinnacle, but merely another step in an endless journey? Some believe that evolution is incomplete, that there must be something more, something unseen. The complexity of life, they argue, is too vast, too intricate to be the result of random mutations and natural selection alone. Could there be hidden forces at work, shaping life in ways we do not yet understand? Or is it simply that our understanding of evolution, like so many things in science, is still in its infancy? And yet, the beauty of evolution is not in its certainty, but in its mystery. It is a story still being written, a puzzle with pieces that continue to fall into place. With every new discovery, with every fossil unearthed, with every genetic code unraveled, we come closer to understanding the great unfolding narrative of life. But even as we learn, new questions emerge, like ripples spreading across a still pond, inviting us to look deeper, to search further, to never stop wondering. At its heart, evolution is a story of resilience, of change, of life's unbreakable will to persist against all odds. It is the story of creatures who adapted to the ice and the fire, who survived the great extinctions, who found ways to flourish in the harshest of landscapes. It is the story of survival, of struggle, of existence itself. And in that story, we find not just science, but something almost poetic. A reminder that life is not a fixed thing, but a journey, an ever-changing dance across the fabric of time. Heliocentrism. For much of human history, the night sky was a mystery, a vast and eternal dome where stars burned like distant lanterns, fixed and unmoving, circling above an earth that was believed to be the center of all creation. It was a comforting idea, a world where everything revolved around us, where the heavens turned in perfect harmony, designed with humanity at its heart. The sun, the moon, the planets, all were thought to be celestial bodies tracing divine paths across the sky, their movements governed by forces beyond mortal understanding. To challenge this notion was to challenge the very order of existence itself. And yet, there were those who dared to look closer, to ask questions that had long been ignored. The ancient Greeks suspected that the earth might not be the center of everything. Some, like Aristarchus of Samos, whispered the radical idea that perhaps it was the sun, not the earth, that stood at the heart of the cosmos. But such thoughts were dangerous, and the world was not yet ready to listen. The idea faded into obscurity, buried beneath the weight of tradition, waiting for the right moment to resurface. That moment came centuries later, when Nicholas Copernicus, a quiet and meticulous scholar, gazed upon the heavens and saw something different. He studied the movements of the planets, tracing their strange and wandering paths, and found that the old explanations no longer made sense. The erratic loops of Mars, the shifting positions of Venus, the slow, steady glide of Jupiter across the sky, none of it fit the model of an Earth-centered universe. And so, he proposed a new idea, one that would shake the foundations of human understanding. The sun, not the Earth, was the true center of the solar system. It was a revelation, but also a revolution. To say that the Earth moved, that it was just another planet in a cosmic ballet, was heresy to many. It defied religious doctrine, it challenged the wisdom of the ancients, it stripped humanity of its central place in the universe. And yet, the evidence was undeniable. Slowly, painfully, the idea took root, but not without resistance. Copernicus himself hesitated to publish his findings, fearing the backlash they might provoke. He lived his life in quiet contemplation, his great work, De Revolutionibus Orbium Coelestium, released only as he lay on his deathbed, as though he had waited until his final moments to let the world see what he had discovered. But truth has a way of resurfacing, no matter how deeply it is buried. In the decades that followed, others took up the cause. Galileo Galilei, armed with a telescope of his own making, peered into the night sky and saw things that no human had seen before. He watched as the moon revealed its craters and mountains, as the Milky Way resolved into a river of countless stars, as Jupiter's moons danced in their own miniature solar system. And then, the most damning discovery of all, Venus, with its changing phases, proving once and for all that it did not orbit the Earth but the Sun. Galileo spoke the truth, but the world was not ready to hear it. He was met with hostility, branded a heretic, forced to stand before the authorities and deny what his eyes had shown him. Under threat of imprisonment, he recanted, whispering the words that would echo through history. E por si muove. And yet, it moves. Even in silence, the truth remained. The battle between old beliefs and new discoveries raged on. Johannes Kepler refined the model, uncovering the elliptical orbits of planets, proving that their motion was not the perfect circle once imagined, but an elegant dance shaped by unseen forces. And then came Isaac Newton, who revealed the invisible hand that guided the heavens. Gravity, the silent architect of the cosmos, the force that bound planets to their stars and stars to their galaxies. With his laws of motion, the heliocentric model was no longer just a theory. It was an undeniable reality. But acceptance did not come all at once. Even as the evidence mounted, the shift in thinking was slow. Humanity clung to its cherished beliefs, resisting the idea that we were no longer the focal point of creation. It was difficult to accept that the Earth was not unique, that it was merely one of many worlds adrift in the vastness of space. The implications were profound. If the Earth was not special, if the Sun was just another star among billions, then what did that mean for us? Slowly, as generations passed, the heliocentric model became the foundation of astronomy. It opened the door to new discoveries, leading to a deeper understanding of the cosmos. But with that understanding came new questions, each more unsettling than the last. If our world was not the center of the universe, then what else had we misunderstood? What other assumptions were waiting to be overturned? And so, the search for truth continued. The more we learned, the more we realized how little we truly knew. With each passing century, the universe grew larger in our eyes, expanding beyond the boundaries of what we had once thought possible. The Sun, once the center of everything, was revealed to be just one among countless others, a single beacon in the endless night. But in this humbling revelation, there was also a strange kind of beauty. We were no longer at the center, no longer the masters of a universe designed for us alone. Instead, we were wanderers in a vast and ancient cosmos, small but not insignificant, part of something far greater than we had ever imagined. And perhaps in that realization, there was a deeper kind of meaning, one not found in being the center of everything, but in simply being a part of it all. String theory. Beneath the surface of reality, deeper than the smallest atom, beyond the reach of even the most powerful microscope, lies a world so strange, so incomprehensibly small, that it defies every intuition we have about existence. It is a realm where the very fabric of space and time trembles, where the laws of physics begin to blur, where the solid and the tangible dissolve into something far more delicate. It is the world of string theory, a place where reality itself is woven from the vibrations of tiny, invisible strings, oscillating in dimensions beyond our perception. For centuries, scientists have sought the mental building blocks of the universe, peeling back layer after layer, reducing the cosmos to its most essential parts. First, there were the atoms, once thought to be the indivisible bricks of existence. Then, the discovery of protons, neutrons, and electrons shattered that notion. And deeper still, quarks and leptons emerged, revealing that even the particles we once believed to be elementary were composed of something even smaller. But what if the search does not stop there? What if, beneath it all, these particles are not particles at all, but tiny loops of vibrating energy, so infinitesimally small that they exist beyond the reach of observation? Imagine a violin string stretched and ready to sing. A single note played upon it can fill the air with sound, but pluck it differently, and a new note emerges. Now shrink that string down 1 billion times smaller than an atom, down to the very foundation of existence itself. The way it vibrates, the frequency of its trembling, determines what it becomes: a quark, an electron, a photon, or something else entirely. In this theory, all the diversity of matter, all the forces of nature, all the fundamental particles of the universe arise from the symphony of these tiny hidden strings. But there is a cost to this vision of reality, a price that must be paid to unify the laws of physics. Our world, as we experience it, has 3 dimensions of space and 1 of time: up, down, left, right, forward, backward, and time always marching forward. But for string theory to work, the universe must be far more intricate than what we perceive. It demands extra dimensions, 6, perhaps 7, perhaps more, folded, curled, hidden from our senses, compacted into shapes so minuscule that they elude even the most advanced experiments. These dimensions are there, if the theory is correct, coiling beneath the surface of reality like unseen scaffolding, supporting the structure of the cosmos. It is a theory that promises much. In its elegance, it offers a path to the long-sought unification of all forces: gravity, electromagnetism, the strong and weak nuclear forces, woven into a single harmonious equation. For centuries, physics has been divided, a puzzle with pieces that refuse to fit together. Einstein's relativity rules the vast cosmic scale, explaining the bending of space and the warping of time. Quantum mechanics, strange and unpredictable, governs the tiny, chaotic world of particles. They are both true, and yet when brought together, they refuse to agree. But if all things, forces, matter, even space and time itself, are merely different notes played upon vibrating strings, then perhaps the dissonance will resolve, and the great symphony of reality will at last be understood. Yet for all its beauty, string theory remains elusive. No experiment has yet confirmed it. No telescope has seen its hidden dimensions. No particle accelerator has uncovered its tiny strings. It is a theory of shadows, a whisper of something beyond our grasp. Some wonder if it is even real, or if it is merely mathematics spun into dreams. Others believe that one day, with technology beyond what we now possess, we will at last glimpse the threads from which the universe is woven. But even if string theory proves to be just an idea, it has already reshaped the way we think about reality. It forces us to question what we mean when we say something is real. If the universe is built from invisible, vibrating loops of energy, then what is solid? If space itself curls into unseen dimensions, then what is distance? If all things arise from the trembling of strings, then what is the nature of existence itself? In the end, string theory is not just about physics. It is about perspective. It is a reminder that the universe is far stranger, far more intricate, far more mysterious than we have ever imagined. It whispers that beneath the surface of the everyday world lies a hidden reality, waiting to be understood. It tells us that the journey to truth is never ending, that no matter how much we discover, there will always be deeper layers, stranger answers, more profound questions. And so, as you drift into sleep, let yourself imagine the world as it might truly be, a tapestry of invisible threads, vibrating with the music of existence. Every atom in your body, every star in the sky, every galaxy spinning in the cosmic void, all of them, woven from the same fundamental strands, playing the same eternal symphony. The universe hums with a melody we cannot yet hear, a rhythm beyond our comprehension, a song of strings stretching across the cosmos, filling the void with the quiet music of reality. Let that thought carry you into the depths of rest, into the quiet vastness of your dreams, where unseen dimensions unfold, where time bends and stretches like a whisper on the wind, where the very fabric of the universe trembles with the echoes of infinity. Sleep now, wrapped in the gentle vibrations of a cosmos that sings softly, endlessly beyond the reach of time. Multiverse Theory. Close your eyes and picture the universe. Imagine its vastness, stretching in every direction, an endless ocean of stars and galaxies, each drifting through the void like lanterns in the night. It feels infinite, boundless, the only reality there is. But what if this universe, everything we have ever known, every star, every planet, every breath we have taken, is just one of many? What if, beyond the edges of our understanding, there exist other universes, countless and unknowable, each with its own rules, its own history, its own version of reality? This is the multiverse theory, a whisper from the fringes of physics, an idea both breathtaking and terrifying. It suggests that our universe is not alone, that it is merely one bubble in an infinite sea, a single branch on an ever-splitting tree. The laws of physics, which seem so absolute, might be different elsewhere. time itself might flow in strange and unfamiliar ways. And in some of these universes, perhaps many, there might be other versions of you, living different lives, making different choices, walking down paths that, in this universe, you never took. The idea of the multiverse arises from many places. In quantum mechanics, there's a strange and unsettling notion, the many worlds interpretation. It suggests that every time a decision is made, every time an event could unfold in multiple ways, reality splits. In one world, you chose to turn left. In another, you turned right. In one, you missed the bus. In another, you caught it. Each possibility, each branch is not discarded but continues to exist, playing out in a parallel universe, just as real as our own. If this is true, then every moment spawns an infinity of realities, an endless cascade of diverging timelines, all existing at once. Then, there is cosmic inflation, the idea that the universe expanded from a tiny hot singularity into the vast cosmos we see today. If inflation happened once, what if it happened countless times? Some theories suggest that our universe is just one bubble in an eternal froth, that new universes are constantly forming, each sealed off from the others, forever unreachable. Some may be nearly identical to ours. Others may be so alien that we cannot begin to comprehend them. Places where gravity is weaker, where atoms never formed, where time moves in loops instead of lines. And then, there is the most radical possibility of all. The idea that the multiverse is not just a collection of different physical realities, but a fundamental feature of mathematics itself. Some physicists argue that every possible universe that can exist must exist. Every equation, every logical structure, every possible way of arranging matter and energy, it all exists somewhere in some universe. This would mean that anything that can happen does happen somewhere in some reality. If this is true, then what does it mean to be you? Are you just one version among infinite variations, a single thread in an infinite web? Is the life you are living now the only one that matters, or are there other versions of yourself making different choices, walking different roads? And if every possibility exists somewhere, then what is the nature of fate, of free will, of identity itself? The multiverse theory is intoxicating and unsettling. It forces us to reconsider everything we thought we knew about reality. It suggests that the universe is not just vast, but infinite in ways we can barely imagine. And yet, for all its wonder, there is something profoundly isolating about it. If there are other universes, will we ever reach them? If there are other versions of us, will we ever know them? Or are we forever locked in our own bubble of existence, separated from our alternate selves by barriers we cannot cross? But perhaps, in this vastness, there is also a kind of comfort. If the multiverse exists, then nothing is ever truly lost. Every path that was not taken, every dream that was left behind, every version of ourselves that could have been, they all exist somewhere, playing out in their own way. Every moment, every possibility, every flicker of thought, none of it is wasted. In some universe, it all happens. So as you drift into sleep, let your mind wander through the infinite. Imagine the other versions of yourself, the other worlds where you exist. Perhaps in one, you are an explorer, sailing through the stars. Perhaps in another, you are a poet, writing words that will never be forgotten. Perhaps in some universe, you made a different choice, took a different turn, and your life unfolded in ways you can only dream of. But in this universe, here and now, you are exactly where you are meant to be. Let that thought lull you into rest. The multiverse is vast, endless, unknowable. But in this moment, in this reality, you are here, wrapped in the quiet hum of existence. And as you sleep, the infinite cosmos continues its silent dance, spinning out endless possibilities, weaving the fabric of reality, forever and always. Holographic Universe. Imagine for a moment that everything you see, everything you touch, everything you believe to be real, is nothing more than a projection, a shimmering illusion cast upon the surface of space itself. What if the depth, the vastness, the solidity of the universe is not as it seems, but merely a trick of perspective? This is the idea behind the holographic universe, a theory that suggests reality, as we perceive it, may not exist in the way we think it does. At the heart of this theory lies an unsettling notion that the three-dimensional world we move through, the space we stretch our hands into, the very fabric of our reality, could be encoded on a distant two-dimensional surface, like a shadow cast by an unseen light. Just as a hologram on a credit card appears three-dimensional, but is actually a flat image containing all the information needed to create depth, our universe, too, might be nothing more than a higher dimensional projection of information stored elsewhere. This idea is not merely science fiction. It emerges from some of the most complex and sophisticated physics of our time. It begins with black holes, those dark and mysterious regions of space-time where gravity is so intense that nothing, not even light, can escape. Decades ago, physicists discovered something strange about black holes. When they swallow matter, the information about that matter does not seem to disappear into the abyss. Instead, it is encoded on the event horizon, the two-dimensional surface surrounding the black hole. This led to an astonishing possibility. If black holes store information in 2 dimensions, but still create the illusion of a 3-dimensional world inside them, could our entire universe function in the same way? The mathematics of this idea are compelling. In certain versions of string theory, it turns out that a universe with gravity, like ours, can be perfectly described by equations that exist on a lower dimensional surface. This means that everything we experience, from the warmth of the sun to the thoughts in our minds, could be written on a cosmic boundary we can never reach, just as the intricate folds of a hologram emerge from a flat surface we cannot see. If this is true, then what does it mean to be real? If everything we feel and perceive is merely a projection, then what is consciousness? Are our thoughts, too, encoded on some distant horizon, unfolding in ways we cannot comprehend? Does time itself truly exist, or is it another illusion cast by the rules of this deeper, hidden reality? The holographic principle suggests that information, not matter, is the most fundamental building block of the universe. What we call physical reality may be nothing more than a pattern of information, a vast and intricate code written in a language we are only beginning to decipher. If the universe is a hologram, then what we experience as solid objects, as movement, as distance, are just emergent properties, like the flickering of pixels on a screen, giving the impression of depth where none truly exists. It is a mind-bending idea, one that shifts our perception of everything. If the universe is holographic, then space is not what it seems, and time may be an illusion. The past and future might be encoded together, existing simultaneously, waiting to be read like a vast cosmic record. Every action, every moment, every memory, perhaps they do not vanish into oblivion, but remain, written upon the fabric of reality itself. But for all its strangeness, the holographic principle also offers something profound. The idea that reality, no matter how illusory it may seem, is deeply connected. If the universe is a projection, then every point in space contains echoes of the whole. Every particle, every atom, every star, each is part of a larger pattern, woven together in ways we do not yet understand. It suggests that nothing is truly separate, that everything is part of a single, interconnected whole. As you drift into sleep, let this thought settle into your mind. The world around you, the air you breathe, the warmth of your bed, it all feels real, and in a way it is. But perhaps reality is more than what it appears, more than what our senses can perceive. Perhaps, beyond the edges of our understanding, there is a deeper truth, one we can only glimpse in moments of quiet contemplation, in the stillness before sleep. Let yourself relax into the mystery. Whether the universe is a hologram or something else entirely, whether reality is projected from a hidden dimension or woven from threads we cannot yet see, one thing remains certain. You are here, in this moment, a part of the great unfolding. And as your mind drifts into the vastness of sleep, the universe continues its silent song, whispering its secrets in the language of stars and shadows, waiting for the day when we will finally understand. Quantum immortality. Close your eyes and imagine a world where death is not the end. Not because of some mystical force or divine intervention, but because of the very fabric of reality itself. A world where, no matter what happens, you always survive, at least in some version of the universe. This is the unsettling idea of quantum immortality, a theory that emerges from the many worlds interpretation of quantum mechanics, suggesting that consciousness may never truly cease to exist. To understand this theory, we must first look at the strange and counterintuitive world of quantum mechanics. In the quantum realm, particles do not exist in a single definite state, but in a superposition of possibilities. particle is not here or there, it is both until measured. When we observe it, the wave of possibilities collapses into a single outcome. But what if, instead of collapsing, reality simply splits? What if, at every moment of decision, the universe divides, creating a new reality for every possible outcome? Quantum immortality takes this idea and applies it to human consciousness. Imagine a scenario where your life is in danger. Perhaps you are in a situation where survival is a matter of probability. According to this theory, in some universes, you perish. But in others, against all odds, you survive. And because your consciousness can only experience outcomes where you remain alive, you never perceive your own death. You continue existing in the timeline where you always make it through. It is a haunting idea. If true, it would mean that from your own perspective, you are immortal. Not in the sense of never aging, but in the sense that you never reach a point where you cease to exist. No matter how unlikely survival becomes, there is always a universe where you make it. Pneumon, where some improbable stroke of luck keeps you alive. Even in the most catastrophic events, your consciousness would continue, always slipping into the branch of reality where you endure. But what would such an existence feel like? If you could never die from your own point of view, would the world start to feel increasingly strange? Would the laws of probability seem to bend around you, making you feel like the luckiest, or perhaps the unluckiest person alive? Imagine a reality where you always find yourself in the one version of events where you just barely escape death again and again as the world around you grows more unrecognizable. And what happens when you reach an age where the body can no longer sustain itself? Would quantum immortality still hold? Some theorists speculate that if the mind is tied to quantum processes, then even as the body deteriorates, consciousness might transition to another state, another form of reality. If the self is merely a pattern of information, could it persist beyond physical decay, emerging in ways we cannot yet comprehend? There is an eerie paradox at the heart of this theory. On the one hand, it suggests that you, personally, will never experience your own death. On the other hand, in nearly every version of reality outside your own, others will see you perish. From an external point of view, you are just as mortal as anyone else. But from within your own thread of existence, there is no final moment, only an unbroken continuity, stretching forward forever. But if quantum immortality is true, does that mean suffering is inescapable? If you can never truly die, does that mean you could end up in a universe where pain, isolation, or the collapse of civilization leaves you stranded in a fate worse than death? Could you find yourself in a reality where you are the last conscious being left, trapped in an endless, decaying world? Perhaps, in some ways, it is comforting to think of death as a release, a final stillness. But quantum immortality suggests that there is no release, only the ceaseless unfolding of experience, the relentless persistence of awareness. You will always wake up, always open your eyes, always find yourself existing in some way, somewhere, no matter what. As you let yourself drift into sleep, let these thoughts settle like ripples in a vast ocean. Whether or not quantum immortality is real, whether or not consciousness truly stretches forever, you are here, now, in this moment. And perhaps that is enough. Let go of the questions, the paradoxes, the infinite branching possibilities. Let yourself sink into the present, into the softness of the night, into the quiet hum of existence. And as you sleep, the universe will continue splitting, branching, unfolding, always and forever, in ways we can never fully understand. Cyclic Universe. Imagine a universe that never truly ends. A universe where time itself moves in great, unending loops. Where the past is not lost to history, but destined to return again, and again, and again. This is the idea of the Cyclic Universe, a theory that suggests the cosmos is not a one-time event, not a single explosion followed by inevitable decay, but an eternal cycle of birth, death, and rebirth. For centuries, humans have viewed time as a straight line, moving forward with an arrow that never bends back. We are born, we live, and we fade away. The universe, too, seems to follow this pattern, expanding outward from the Big Bang, stretching into the cold void, destined, perhaps, to end in a slow, quiet death. But what if that is not the case? What if, just as a heartbeat follows another, just as the tides rise and fall, the universe itself follows an endless rhythm? The Cyclic Universe proposes that our cosmos is caught in a repeating loop, where every Big Bang is not the first, but simply one in a long series, an echo of previous universes that came before and the blueprint for those yet to come. Instead of a singular beginning, time stretches in vast cosmic circles, an infinite chain of creations and destructions. Some versions of this theory suggest that at the end of each cycle, the universe collapses in on itself, drawn back into a single, dense point, a reversal of the Big Bang known as the Big Crunch. From there, a new explosion occurs, birthing a fresh cosmos, just as vibrant and full of possibilities as the one before. Others propose that instead of collapsing entirely, the universe slows to a near standstill, where dark energy resets the cosmos in a way we have yet to understand, sparking a new beginning from the remnants of the old. If this is true, it would mean that everything happening right now has happened before and will happen again. Perhaps in another cycle of the universe, you are sitting in the same place, thinking the same thoughts, experiencing the same moment, unaware that you have done so countless times before. Or perhaps, in some distant loop, the patterns shift slightly, minor variations playing out, leading to worlds just a little different from this one. It is a comforting thought, in some ways. If the universe is cyclic, then nothing is truly lost. Every sunset, every memory, every fleeting moment of joy or sorrow, they are not swallowed by time, but simply set aside, waiting to rise again in some future echo of existence. Even the stars, when they burn out, may not vanish forever, but instead become part of the cosmic churn, reborn in the furnace of the next cycle. But what does this mean for us, for consciousness, for the idea of identity? If the universe loops endlessly, do we, too, repeat? Do our lives play out again and again, caught in an eternal recurrence? Is there some version of you in a past cycle, gazing at the stars, pondering the same mysteries, just as you are now? And if we are destined to return, does that mean our choices matter? Or are we simply following a script, replaying events that have already happened, unable to change the course? Perhaps in each new cycle there is a moment, a fleeting chance where something shifts, where we break free from repetition and carve a new path. But for now, there is only this moment, this breath, this quiet drift into sleep. The universe, whether cyclic or linear, is vast beyond comprehension, and yet you are a part of it, a single thought in the mind of time. Let yourself rest in that knowledge. Let the stars spin in their eternal dance. Let the cycles unfold as they always have. And as your mind drifts into the depths of sleep, the universe will continue its rhythm, whispering its secrets in the language of infinity, waiting for the next beginning. Existence of white holes. Close your eyes and imagine a place in the universe where nothing can ever enter. Only escape. A place where time itself seems to flow in reverse, where light, matter, and energy are pushed outward in an unrelenting torrent, never to return. This is the strange and elusive idea of a white hole, the theoretical opposite of a black hole. Unlike its dark counterpart, which devours everything in its gravitational grip, a white hole is thought to be a cosmic fountain, spewing out everything that crosses its event horizon and never allowing anything to fall in. The concept of white holes emerges naturally from Einstein's equations of general relativity, the same equations that predict the existence of black holes. If black holes represent regions where gravity is so intense that nothing, not even light, can escape, then mathematically, there should be a counterpart, a region where nothing can enter, only exit. It is as if the universe has places where reality itself is flipped, where the gravitational pull that traps everything inside a black hole instead works in reverse, pushing everything away. But if white holes exist, where are they? Unlike black holes, which reveal themselves through their immense gravitational effects on surrounding matter, white holes should be impossibly bright, constantly expelling energy, matter, and radiation. Yet, despite our most powerful telescopes scanning the cosmos, we have never observed one with certainty. Some physicists believe they may exist in regions of the universe where we cannot see them, hidden behind the veil of extreme cosmic distances, or even within the centers of galaxies. One of the most fascinating ideas is that white holes might actually be the other side of black holes. When something falls into a black hole, it disappears from our universe, its information seemingly lost forever. But what if that information is not lost, but instead expelled elsewhere through a white hole? If this were true, black holes and white holes could be connected like two ends of a cosmic tunnel, forming what we call a wormhole, a bridge between distant parts of the universe, or even between different universes entirely. This idea leads to an even more radical possibility, that the Big Bang was a white hole. If a black hole collapses to an infinitely small point, then perhaps somewhere else in the cosmos, that same point expands outward in an explosion of energy and matter. Some physicists have speculated that our entire universe could be the result of such an event, a white hole expelling the remnants of a collapsing black hole from another reality, birthing the cosmos as we know it. But if white holes exist, why do they seem so rare? Some suggest that they might be incredibly short-lived, appearing only for a fraction of a second before dissipating into nothingness. Others believe that they might only exist under extreme conditions, forming in the aftermath of black hole deaths, or appearing briefly in the quantum foam of the universe at microscopic scales. There is another unsettling question. What happens if you get too close to a white hole? While falling into a black hole would stretch and crush you with its immense gravitational force, approaching a white hole would be just as impossible, but in a different way. Instead of pulling you in, it would violently repel you, like a force field made of raw space-time. You could never reach its core, just as you could never escape a black hole's interior. The very fabric of physics would conspire to keep you away, pushing you endlessly backward, denying you entry into its secrets. The mystery of white holes is one that lingers on the edge of our understanding, a tantalizing possibility that challenges our deepest assumptions about space, time, and reality itself. If they exist, they could rewrite our understanding of the cosmos, offering a glimpse into hidden forces shaping the universe in ways we cannot yet comprehend. As you drift into sleep, let your mind wander into the great unknown, where cosmic riddles stretch beyond the horizon of thought. Whether white holes exist or not, the universe remains a place of endless possibility, a vast and intricate mystery waiting to be unraveled. And as you close your eyes, remember that somewhere, beyond the stars, beyond time itself, there may be places where light does not fall inward, but instead bursts forth, where the laws of reality turn inside out, whispering secrets we are only beginning to hear. Quantum Mind. Close your eyes and imagine your thoughts floating like waves on a vast, invisible ocean. An ocean not of water, but of probabilities, where reality itself exists in a superposition of possibilities. This is the strange and profound idea of the quantum mind, a theory that suggests consciousness itself may be woven into the deepest fabric of the universe, operating not through classical physics, but through the enigmatic principles of quantum mechanics. For centuries, scientists and philosophers have struggled to explain the nature of consciousness. What is it that makes us aware? Why do we experience reality subjectively, feeling emotions, making decisions, and contemplating our own existence? Some believe that the answer lies in the neurons of the brain, in the intricate web of electrical signals firing in predictable patterns. But the quantum mind theory proposes something radically different. That consciousness is not just a product of biology, but of quantum mechanics, the strange rules that govern the subatomic world. Quantum mechanics tells us that particles exist in a state of probability until they are observed. Electrons, photons, even atoms do not have fixed locations or states until measured. Before that, they are waves of possibility, existing everywhere and nowhere at once. Some researchers have suggested that this uncertainty, this ability to be in multiple states at once, might also apply to consciousness itself. Could our thoughts, our decisions, even our sense of self, be shaped by quantum effects occurring deep within the brain? One of the leading theories in this field is orchestrated objective reduction, OR, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They argue that consciousness is not just a byproduct of neural activity, but a fundamental process rooted in the tiny structures within neurons called microtubules. These microscopic tubes, according to the theory, act as quantum processors, allowing the brain to tap into the hidden complexities of the quantum world. If this is true, then human thought is not just electrical signals in the brain, it is a quantum computation interacting with the very structure of the universe. This idea has profound implications. If consciousness is linked to quantum mechanics, it might mean that the mind is not entirely bound by the classical rules of physics. Could it be that decisions, memories, even awareness itself, arise from quantum superpositions collapsing into reality? If so, this would explain why human thought sometimes appears unpredictable, creative, and nonlinear, just like the behavior of quantum particles. But it gets even stranger. If consciousness has a quantum nature, then it may not be confined to the brain at all. Some theorists speculate that the mind could be entangled with the universe itself, existing in a kind of quantum network that extends beyond the physical body. This would mean that consciousness is not just an emergent property of neurons, but something more fundamental, a force that exists beyond space and time, connected to the deeper workings of the cosmos. If this is true, it could change everything we know about life and death. When the body dies, does consciousness vanish? Or does it persist in some quantum form, existing as a pattern of information encoded in the universe? Some have even suggested that near-death experiences, visions, and altered states of awareness might be glimpses into this quantum realm, like moments where the mind temporarily steps beyond the limits of the physical world. The quantum mind theory also raises questions about free will. In classical physics, every action has a predetermined cause, but in quantum mechanics, outcomes are probabilistic. If our minds operate at a quantum level, does that mean our decisions are not preordained, but rather the result of collapsing wave functions, flashes of possibility resolving into reality? If so, then perhaps we are not just mechanical beings following a script, but conscious entities capable of influencing the very flow of existence itself. Yet, despite its allure, the quantum mind theory remains controversial. Many neuroscientists argue that the brain is too warm, too wet, and too noisy for delicate quantum effects to play a significant role. Quantum coherence, they say, is easily disrupted by environmental factors, making it unlikely that quantum superpositions can exist long enough in the brain to influence thought. And yet, nature has defied expectations before. Birds use quantum effects for navigation, plants use them for photosynthesis, and quantum tunneling occurs in biological enzymes. If life has already found ways to harness quantum mechanics, could the brain be doing the same? Time travel. Close your eyes and imagine stepping outside the flow of time, breaking free from the relentless forward march of seconds, minutes, and years. Imagine walking through a door and finding yourself in the past, standing in a world that no longer exists, where every choice you make could unravel history as you know it. Or picture yourself leaping forward, skipping over centuries in a heartbeat, witnessing the rise and fall of civilizations yet to come. This is the mind-bending possibility of time travel, a concept that has fascinated philosophers, scientists, and dreamers for centuries. Time, to our everyday experience, feels fixed, an unbreakable current pulling us forward. We live our lives moment by moment, with no way to turn back, no way to pause, no way to leap ahead. But physics tells a different story. According to Einstein's theory of relativity, time is not an absolute constant. It stretches, bends, and warps depending on speed and gravity. The faster you move, the slower time flows for you relative to those at rest. If you could travel near the speed of light, time for you would nearly freeze, while the rest of the universe would continue aging. In effect, you would step into the future, leaving the present behind. But what about traveling to the past? This is where time travel becomes even more mysterious, tangled in paradoxes that challenge our understanding of cause and effect. If it were possible to go back in time, what would stop you from changing the very events that led to your own existence? What would happen if you prevented your parents from meeting or altered a pivotal moment in history? This is the grandfather paradox, one of the many logical knots that make backward time travel seem impossible. And yet, some theories suggest that nature may have built-in safeguards. The Novikov self-consistency principle proposes that if time travel to the past were possible, events would always align in such a way that paradoxes could never occur. If you traveled back in time and attempted to change something crucial, the universe would correct itself, ensuring that history remains unchanged. In this view, the past is not a blank slate to be rewritten, but a fixed tapestry, where every thread is woven in a way that prevents contradiction. Then there is the many worlds interpretation, which suggests that every choice, every possibility, splits reality into countless parallel universes. If you traveled to the past and altered an event, you wouldn't change your own timeline. You would create a new one, branching off into an alternate reality. Your original timeline would still exist, untouched, while a new universe would unfold with the consequences of your actions. If this is true, then every moment, every decision is birthing infinite versions of reality, where every possible outcome is playing out somewhere, in some distant corner of existence. One of the most intriguing possibilities for time travel lies in the concept of wormholes. Shortcuts through space-time, connecting distant points in both space and time. These theoretical tunnels, predicted by Einstein's equations, could allow an object, or even a person, to bypass the normal flow of time, stepping through one end and emerging in the past or future. But if wormholes exist, they are likely microscopic and unstable, requiring vast amounts of exotic matter to keep them open. Whether they could ever be traversed remains an open question. And yet the universe may already offer glimpses of time travel in ways we don't fully understand. Quantum mechanics presents strange phenomena like quantum entanglement, where particles appear to influence each other instantaneously, seemingly defying the limits of time. There are also peculiar experiments where particles seem to remember information from the future, as if time is not as rigid as we believe. Could it be that time travel is already happening at the quantum level in ways that we have yet to comprehend? There are even scientists who speculate that we may already be living in a time loop, repeating our existence over and over without realizing it. Some versions of the Cyclic Universe theory propose that time itself may be circular, with the universe collapsing and rebirthing in an endless cycle. If this is true, then every moment you experience may have happened before and will happen again forever. Theory of evolution. Close your eyes and imagine a vast, endless timeline stretching back billions of years. A timeline where life, in its simplest form, emerged from the quiet depths of a primordial ocean, growing, adapting, and diversifying into the countless forms that have walked, swam, and flown across this planet. The theory of evolution, first brought into sharp focus by Charles Darwin, suggests that life did not appear fully formed, but rather it unfolded like a grand, cosmic story, one shaped by the forces of nature, time, and the relentless drive to survive. Evolution is not a single event, but a slow, steady dance between life and its environment. Every living thing, from the tiniest microbe to the towering trees of ancient forests, carries within it the silent traces of its ancestors. It is written in the language of DNA, a code passed down through countless generations, a record of struggles, adaptations, and the unyielding will to continue. But evolution is not just a story of survival. It is a story of change, of tiny, imperceptible shifts that, over immense spans of time, transform one species into another. The process is guided by natural selection, a mechanism so simple and yet so powerful that it has sculpted the diversity of life on Earth. Picture a group of animals facing a harsh winter. Some have thicker fur, others do not. Those with thicker fur survive, pass their genes to their offspring, and over generations, the population slowly becomes better suited to the cold. It is not a conscious effort, not a deliberate choice, but a gradual refinement, like the wind carving patterns into stone. But evolution is not a straight line, and nature does not move with intention. The fossil record reveals a chaotic history, full of dead ends and lost branches, species that thrived for millions of years before vanishing, their only remnants buried beneath layers of rock. Some, like the dinosaurs, ruled the Earth until a cosmic catastrophe ended their reign, making way for new forms of life to rise in their place. Others, like early human ancestors, faced shifting landscapes and changing climates, forcing them to adapt, to think, to innovate. One of the most fascinating aspects of evolution is that it operates without a goal. There is no end destination, no ultimate form of life that nature is striving to create. Humans are not the pinnacle of evolution, but simply one branch in an ever-growing tree. Life does not move toward perfection, only toward survival. Some species remain virtually unchanged for millions of years, while others evolve rapidly in response to their surroundings. Evolution is not about progress, it is about persistence. Yet, despite the overwhelming evidence, the theory of evolution remains one of the most debated and controversial ideas in science. Some struggle to accept that life could emerge and transform without guidance, without a guiding hand shaping its course. But the beauty of evolution is that it does not require direction. It is a self-sustaining process, a natural consequence of variation, inheritance, and selection. Life flourishes not because it was designed to, but because it must. At the heart of evolution lies a deep, almost poetic truth, that every living thing on Earth is connected. The tree in your backyard shares a distant ancestor with the grass beneath it. The birds in the sky, the fish in the ocean, the insects buzzing in the night, all are part of the same great family, linked by billions of years of shared history. Even you, with your thoughts, your dreams, your memories, carry within you the echoes of ancient creatures that once roamed this planet. As you drift into sleep, let this idea settle into your mind like the slow unfolding of time itself. Life is not static, it is not fixed, it is always changing, always becoming. And just as the world around you shifts and transforms, so too does your own existence, shaped by the unseen forces of time and nature. In the quiet hum of the universe, in the whispers of the past carried through your DNA, lies the story of everything that has ever lived. Let that thought guide you into rest, into the soft embrace of night, as you become one with the endless flow of time.